In this walkthrough we are looking at a practical support problem, SQL blocking versus SQL deadlocks. To an end user, both can feel the same. A screen hangs, a save button spins, a job times out, or an update fails. But under the surface they are different behaviors and they need different evidence. The aim is to move from vague performance complaints to a clear support explanation: what is waiting, what caused it, what should be done now, and how the repeat incident can be prevented. Blocking is one session waiting behind another session. That can be completely normal for a short period of time. It becomes an incident when the blocker stays open too long or affects important workloads. A deadlock is different. It is not just a long wait. It is a cycle where two or more sessions each hold something the other needs. SQL Server breaks the cycle by choosing one transaction as the victim and rolling it back with error 1205. The quickest mental model is queue versus cycle. Blocking is a queue. SPID 57 holds a lock and SPID 62 waits behind it. If SPID 57 commits or rolls back, SPID 62 can continue. A deadlock is a cycle. SPID 57 holds the account row and wants the ticket row, while SPID 62 holds the ticket row and wants the account row. Neither can progress, so SQL Server intervenes. The demo uses one lab database called support desk_blocking these deadlocks. There are two tables, customer account and support ticket. The slides use fixed teaching labels, session A as SPID 57 and session B as SPID 62, so that the screenshots and results stay consistent. On a real system, SQL Server will allocate different SPIDs, so the method matters more than the specific numbers. To reproduce blocking, session A starts a transaction and updates account ID 1001. It then leaves the transaction open. Session B attempts to update the same row. Session B does not immediately fail, it waits. This is a classic blocking incident. The important support point is that the blocked session is normally the symptom, not the root cause. The first blocking query uses sys.dm_exec_requests and sys.dm_exec_SQL_text. The result shows SPID 62 is suspended, waiting on LCK_M_X, and is blocked by SPID 57. That gives us the evidence chain: affected session, blocking session, wait type, wait time, database, and running statement. At this point the lead blocker is SPID 57, not SPID 62. Once the lead blocker is known, inspect the transaction age, login, host, program name and most recent SQL text. Then look at logs for the blocked and blocking sessions. In this example, SPID 57 has the granted exclusive lock and SPID 62 is waiting for a conflicting exclusive lock. This is the difference between saying SQL is slow and saying exactly which transaction is holding up the work. The deadlock demo uses the same two tables but changes the order of access. Session A updates customer account first and then support ticket. Session B updates support ticket first and then customer account. This creates a circular dependency. One session will receive error 1205 and SQL Server will roll that transaction back. A deadlock usually disappears immediately because SQL Server has already resolved it by selecting a victim. That means current blocking DMVs may show nothing useful afterwards. The evidence is the deadlock report, usually collected with extended events. In the lab, we create a small extended events session that captures XML_deadlock_report into a ring buffer. The deadlock graph has three important areas: the victim list, the process list and the resource list. The victim list tells us which process was rolled back. The process list shows the sessions, SQL text and transaction state. The resource list shows the locked objects or keys and the conflicting lock modes. The goal is to identify the cycle, not to blame the victim session automatically. The durable fix is to make the cycle impossible. The common fix is consistent access order. Every code path should update customer account first and support ticket second. Transactions should also be kept short, search predicates should be indexed, and the application should retry error 1205 safely. Retry logic is important, but it is not a substitute for fixing the transaction pattern. Blocking and deadlocks are related but not the same. Blocking is usually a queue. Deadlocking is a cycle. Support analysts add real value by proving which one they are dealing with, explaining the immediate impact, and recommending the correct prevention step. Use the script and checklist from this pack as a repeatable workflow for SQL Server incident investigation.